Hello, now I am going to talk about statistical process control in service industry and an application with real data in a commercial company. And the presentation goes like this. Introduction, Shiva type control charts, methodology for applying control charts to sales department. Introduction. The main purpose of this article is to present the advances of statistical process control techniques in non-manufacturing processes. Specifically, in this report, we present two applications of control charting techniques in the commercial company. Application of control charting techniques in the sales department. 2. Application of control charts in the logistic department. The principal application domain for statistical process control charts has been for process control and improvements in manufacturing business for about 50 years. The most common process control technique has been control charting. A control chart is useful that aids practitioners in statistically controlling and monitoring one or more variables. When the quality of the product or the quality of the process is characterized by certain values of this or these variables, by the term controlling, we mean the ability of the control chart at any time to determine if the process or the product characteristic is statistically in control. The term statistically in control process reflects to the process that operates with only chance cause of variation. A process that is operating in the presence of assignable causes is said to be statistically out of control. In general, a control is very easy to be implemented in any type of process. Thus, control charts are extensively used in manufacturing area nowadays, preserving the quality of the process or the final product. The controlling and monitoring is done over either the mean level or the variance level of the process or the quality characteristic. Year 2004, more than 80 articles have been identified in the literature that deal with non-standard applications of SPC charts. Broadly, four application domains are mainly identified: engineering, industrial and environmental applications, healthcare applications, general service sector applications, statistical applications. Four principal objectives have been identified in reported studies. Process monitoring. This is an extension of the conventional application of control charts to a much wider range of processes. As with conventional applications, the objectives are to monitor and control a process in order to maintain process stability and in many cases to enable process improvement. For this group of applications, it is worth distinguishing between those applications for which conventional Shiva charting techniques are deemed appropriate and those are applications that require other techniques. Coming to planning, charts are used in number application domains to derive effective plans or schedules, particularly for maintaining scheduling. This may be a type of application for SPC charts with potential for wider use. And next, to evaluating customer satisfaction. SPC charts are used to evaluate customer satisfaction in a range of application domains to detect high levels of satisfaction and dissatisfaction. This may also be a type of application for SPC charts with potential for wider use. And the last one is SPC charts are used to generate or optimize a forecasting model. This may be considered a statistical or technical application of SPC charts with some potential for wider use, specifically in forecasting applications. Now we move on to the chapter of our presentation, Shiva type control charts. A Shiva type control chart is a graphical display of a process or a product quality characteristic that has been measured or computed from a sample versus the same number or time. The basic characteristics of a univariate process control chart are the central line C, which is CL, the upper control limit UCL and the lower control limit LCL. The ordinary rule applicable to Shiva type control chart for declaring a possible out of control condition in a manufacturing process is the occurrence of a point outside the control limit. Here we can see figure 1 and 2 control charts for controlling the mean and the variance of quality characteristics which are given. In addition, many sensitizing rules have been suggested for the Shiva control charts in order to make them more sensitive in the detection of drifts in the mean of the process. There are two distinct phases of control charts and phase 2. Phase 1 charts are used for retrospectively testing whether the process was in control when the first subgroups were being drawn. In this phase, the charts are used as aids to the practitioner in beginning a process into a state of statistical in control. Once this is accomplished, the control chart is used to define what is meant by statistical in control. In phase 2, control charts are used for testing whether the process remains in control when future subgroups are drawn. Now let's move on the third chapter of our discussion, methodology for applying control charts to sales department. In this session, we present the basic ideas of applying Shiva type control charts in sales data. The company that concerns this study is a commercial enterprise in the area of furnishing. The problem which we are going to deal with is the department of sales consists of K salesmen. The data that we have in our hand concern the weekly sales of each one of the K salesmen. From July 2nd, 1974 till February 25th, 2005, N is equal to 5 days, a week measurements, and M is equal to 30 weeks in total. Furthermore, we define the weekly sales of each salesman by Sij for I is equal to 1, 2 and so on 30 and J is equal to 1, 2 and so on K. The sum of the sales of K salesmen will be symbolized with Sit for I is equal to 1, 2 and so on 30. For Si capital T is sum of the K random variables. The ratio of the sales of each salesman weekly as for the total sales of the week is defined as Rij for I is equal to 1, 2 and so on 30 and J is equal to 1, 2 and so on K. Thus, in order to check the stability and the attribution of each salesman, we apply K independent Shiva type control charts for individual observations. The assumptions to solve this problem are: we suppose that the sales of the K salesmen are independent among them. Actually, this cannot be valid since the sales of each one of the salesmen is influenced by the state of sector's market, which is reflected in the total sales of the company. Another assumption that we make is that the weekly sales of each salesman are time independent. Such a hypothesis also may not be valid because of the fact that the sales are influenced by seasonality in the particular market. Finally, we suppose that the sales follow the normal distribution. This hypothesis is verified. Applying Shiva type control charts for individual observation Sij in each one of the K salesmen, ignoring the cross correlation and also ignoring the auto correction of measurements, we may drive wrong conclusion that the sales activity is out of control. We can see X chart for D and MR2 chart for D. In figure 3, the control chart for individual observations for controlling the mean week sales as well. In figure 4, the appropriate control chart for monitoring the variance of sales activity for the salesman D is given. Let's move on to multivariate control chart. In order to take into account the cross correlation among variables, a multivariate control chart may be applied. This control chart is known as T-square Shiva type control chart. As it appears in figure 6, the sales of K salesmen actually are under a stable state, meaning that the sale process is statistically in control. Examine more carefully The t-square control chart, we may observe a random repeated pattern. This means that the ti square values for I is equal to 1, 2 and so on 30 may be inside the control limits, but they are far away from the line 0, the base graph. This fact is owned by the autocorrelation, as we may easily conclude by observing Figure 7 and 8. There is statistically significant autocorrelation among the values of Ti square. When we face such a problem, we have two choices. The first choice is to model our observation making use of some suitable time series model. However, the problem of independent control of each one of the salesmen will still remain same. For this reason, we select the second alternative in order to control the quality Rij, which is equal to Sij divided by Si capital T. The use of this quantity allows us almost the independent control of each salesman, since in this way we remove a significant part of autocorrelation among observations. The Rij indicator is a ratio of two related normal random variables and its distribution is known. Using the above defined ratio, by observing figures 9 and 10, we may see that the previous extracted conclusion that the sales process of the salesman D is out of control is false. And I conclude that the aim of this article is to present the potential use of control charting in non-industrial processes, the use of the statistical quality control processes in commercial companies or generally in non-industrial processes may be valuable tool in the machinery of the managers in evaluating employees, departments and services.